All right, ready to dive into some serious AI research?
Always.
Today, it's all about this paper with a name that sounds like, well, a rocket launch.
Yeah.
Flashinfer, efficient and customizable attention engine for LM inference serving.
It's a mouthful.
It is, but trust me, the content is worth it.
Oh, absolutely.
We're talking about large language models or LLMs.
The tech behind those AI writers and chatbots everyone's using.
Exactly. And this paper, it's all about making them faster.
And more adaptable, which is crucial.
Right. Because LLMs can be a bit, well, slow sometimes.
Especially when you need them to do something complex, you know?
Like processing tons of information.
Yeah, exactly.
So this Flashinfer system, they're basically giving LLMs a serious upgrade.
That's a great way to put it.
But to understand how it works, we got to start with a bottleneck.
A bottleneck.
Yeah, like rush hour traffic, but for AI.
Ah, I see what you mean.
So the paper talks about the attention bottleneck.
Right, which is a core part of how LLMs process information.
It's how they figure out what's important in a huge chunk of text.
But it can be computationally expensive, meaning it takes a lot of power and time.
So like the LLM is trying to read a whole library and find the main plot.
Kind of. No wonder it gets bogged down sometimes.
And that's where Flashinfer comes in, right?
Exactly. It's designed to speed up that attention process.
Making LLMs respond much faster.
Exactly.
Okay, that makes sense. But how does it actually work? The paper mentions a block-sparse format.
Right. It sounds complicated, but it's actually pretty simple.
Okay, I'm listening.
Imagine instead of storing every single detail, you just focus on the most relevant chunks of information.
So like having a super organized filing cabinet.
Exactly. That's what the block-sparse format does for LLMs.
It saves memory and makes processing faster.
Precisely.
So it's like Marie Kondoing the LLM's brain.
Haha, I like that. Keeping only what sparks joy.
Right. And that means the AI can find the information it needs faster.
Leading to quicker responses?
No more waiting around for the chatbot to catch up.
Exactly. And it gets even more interesting when you think about repetitive information.
Oh, okay, like when I'm trying to get my smart speaker to understand what I mean.
Right. Or if you keep mentioning the same phrase in a conversation with an AI.
Usually the LLM would have to reprocess that phrase every time.
Exactly. But Flashinfer uses something called composable formats for shared prefixes.
So it recognizes that pattern and optimizes how it stores the information.
You got it. The LLM is actually learning from the conversation.
And becoming more efficient. That's incredible.
It's like it remembers and adapts instead of redoing the same work.
That's so cool. And the paper mentions a customizable attention template.
Oh, yeah, that's a powerful feature.
It sounds like we can actually reprogram the LLM to focus on different things.
Absolutely. Developers can fine-tune Flashinfer for specific tasks.
So it's not just a speed boost. It's a targeted, adaptable speed boost.
You got it.
Wow, I could already see how this would be a game changer for so many things.
It opens up a world of possibilities.
All right, so tell me, how did they test this Flashinfer system?
They ran a bunch of experiments with real-world LLM applications.
Like chatbots and text generation tools.
Exactly. And the results are really impressive.
Okay, let's build a T.
They found that Flashinfer significantly improves speed and responsiveness.
Across the board. So it's not just theoretical, it actually works in practice.
Exactly.
So Flashinfer, new champion of LM efficiency.
It definitely has the potential to be.
This is amazing. But let's give our listeners a moment to process all of this.
Sound good.
When we come back, we'll dig deeper into some of those specific results.
And see what this all means for the future of AI.
It's going to be fascinating. Stay with us.
Welcome back. We're diving deeper into Flashinfer.
I'm still amazed by how much it speeds things up.
It's pretty incredible.
You mentioned some specific results earlier, like parallel generation and long context inference.
Yeah, those are some heavy-duty AI tasks.
Can we break those down a bit?
Sure. Let's start with parallel generation. Imagine using AI to write different creative text formats, like poems or code, all at the same time.
Whoa, so instead of just writing one poem, it could write a sonnet, a haiku, and a limerick all at once.
Exactly. And Flashinfer makes that process even faster.
How so?
By applying that same concept of recognizing shared prefixes we talked about before.
So if the AI is generating different outputs that start with similar phrases, it can recycle some of that work.
Exactly. It avoids redundant processing, which makes the whole thing much more efficient.
That's smart. And what about long context inference?
That's about LLMs processing really large amounts of text.
Like analyzing a huge document or summarizing hours of audio.
Exactly. The AI needs to keep track of a ton of information.
I can see how that would be a challenge.
And that's where Flashinfer's block-sparse format and dynamic scheduling really shine.
Remind me how those work again.
It's all about focusing on the most relevant information and distributing tasks efficiently.
So it's like giving the LM laser focus and a superpowered work ethic.
That's a great way to put it. And they saw big speedups in long context inference tasks.
Wow. Imagine researchers analyzing years of scientific papers in seconds.
Or legal teams sifting through mountains of documents.
The possibilities are mind-boggling.
Absolutely. Speaking of huge amounts of data, you mentioned streaming LLM, which can handle millions of words.
Millions. That's insane. How does it even process all that without exploding?
It's a special technique designed for those massive amounts of information.
So it's like a memory-saving strategy for these supersized LLMs.
Exactly. And Flashinfer helps make streaming LLM even more efficient. They
Wow.
developed specialized attention kernels within Flashinfer to work with streaming LLM.
So they customized it to be a perfect match for this new method.
You got it. It involves some technical details, but the key is that Flashinfer is super adaptable.
So like a chameleon, changing to fit the situation.
Exactly. It maximizes efficiency no matter what.
You mentioned a reduction in latency with this combo.
Latency just means delay.
Mhm.
And in AI, any reduction is a huge win.
So things happen faster, responses are quicker, less waiting around.
Exactly. And remember, this is with streaming LLM, which is already efficient.
So even further improvements are remarkable. You also mentioned they tested it against another library.
Yes, they compared it to the Flash Attention library.
And how did Flashinfer do?
It consistently outperformed Flash Attention, especially with varying sequence lengths.
So it's setting a new standard.
It seems that way.
Okay, last question before we move on. You mentioned composable formats.
Right. Another way Flashinfer optimizes efficiency, especially with shared prefixes.
So it's like a super efficient packing system for information.
That's a great way to put it. No wasted space. Everything fits perfectly.
And this is particularly important for parallel generation, right?
Absolutely. It streamlines the process when the LLM is juggling multiple outputs.
All of this is incredibly promising, but I'm sensing there's more to the Flashinfer story.
You're right. There's one more key area, how it enhances parallel decoding.
Decoding sounds intense.
It's a crucial part of how LLMs generate text. It's taking all the information and turning it into human-readable language.
Gotcha.
Yeah.
So parallel decoding is doing that multiple times at once.
Exactly. Like translating a book into multiple languages simultaneously.
Wow. And Flashinfer makes that more efficient.
By leveraging those composable formats we talked about, avoiding redundant work.
So same principle, different application.
Precisely. Imagine multiple responses starting with the same phrase.
Flashinfer recognizes that and optimizes the processing,
You got it. It speeds up the whole operation.
like a superpowered copy-paste for AI.
And this has big implications for AI agents.
AI agents, those futuristic helpers we hear about.
Yes. AI is designed to perform tasks or interact with the world. Virtual assistants, managing your schedule, controlling smart home devices.
Okay, that's very cool.
And parallel decoding is essential for making them quick and responsive.
Right, you don't want your AI assistant taking forever to do something simple.
Exactly. And Flashinfer helps make those AI agents faster.
That's great. So how did they test this?
They integrated Flashinfer into a popular LLM serving framework called MLC Engine.
Did it work?
They saw significant speedups, especially with moderate parallel generation.
Wow. Flashinfer. Speeds up complex tasks, handles tons of data, makes AI agents more efficient.
It's definitely versatile.
What can it do?
Good question. There's one more detail. Flashinfer handles shared prefixes in parallel decoding differently than some other systems.
Oh, how so?
It avoids separate KV cache management.
Hold on, KV cache, what's that?
To put it simply, it's a separate memory storage that some systems use to handle prefixes.
A special box for those repeated bits of information.
Exactly. But Flashinfer uses those composable formats to manage everything together.
So a more streamlined process.
You got it. And this makes Flashinfer easier to integrate into existing systems.
Because there's no need to modify their memory management.
Exactly. It's a more elegant solution.
So Flashinfer is faster, more efficient, and plays well with others.
That's a great way to put it. And I think it speaks to the bigger impact of this research.
What do you mean?
Flashinfer isn't just about improving one thing. It's about creating a more flexible and efficient foundation for the future of AI.
That's a great point. We've covered a lot, and it's exciting to see how these advancements are pushing the boundaries.
We're just scratching the surface.
Let's take a break to let everything sink in.
Sounds good.
When we come back, we'll step back and look at the bigger picture of what this means for all of us. Welcome back to our deep dive into Flashinfer. It's been a wild ride.
It has.
We've gone deep into the technical stuff, but now I want to zoom out a bit.
Great.
What does all of this mean for the future of AI? Big picture stuff.
That's the million-dollar question, isn't it? It's like predicting the future, but based on what we've seen with Flashinfer,
Yeah.
I think some pretty exciting changes are coming.
Like what? Give me some examples.
Well, think about it. AI is already changing how we live, how we search for information, even how we create art. But there's still a gap between what AI can theoretically do and what's actually practical, like for everyday use.
Ah, I see what you mean.
It's like having a super fast sports car, but being stuck in traffic.
All that power, but nowhere to go.
Exactly. And that's where Flashinfer comes in. It's not just about speed. It's about making LLMs more efficient, more adaptable.
So they can handle the real world better.
Exactly.
So we're clearing the traffic jam for AI.
You got it. Imagine, like, AI-powered medical diagnoses that can analyze years of patient data in seconds, giving doctors insights in real time.
Wow, that would be incredible.
Or AI-assisted legal research, sifting through tons of documents to find the key precedents.
Saving lawyers so much time.
Right. And it's not just specific applications.
What else?
Flashinfer's focus on being customizable and open source,
Okay.
that could really speed up innovation across the whole AI field.
Because more people can work with it, experiment with it.
Exactly. It's like a collective brain power boost.
And the researchers are already thinking about next steps.
Right, yeah, exploring even more advanced techniques.
To make it even better.
Exactly. It's a fast-moving field. We're just at the beginning.
So if our listeners take away one thing from this deep dive, what should it be? The big takeaway.
I think it's this. Flashinfer isn't just a technical thing.
Okay.
It's a glimpse into the future, where AI becomes even more integrated into our lives, not like some sci-fi thing,
Right.
but as a tool that can help us solve real problems.
That's a great point. It's not about AI taking over, it's about working with AI.
Exactly. To augment our abilities, tackle challenges in new ways.
And it makes you think, as these LLMs get faster and more capable,
Right.
how will that change things for us?
Yeah.
How we work, how we learn, even how we interact with the world around us.
It's definitely something to think about.
Maybe some of our listeners will be inspired to contribute to this field.
That would be great. The more minds working on this, the better.
Absolutely. Well, thanks for joining me on this deep dive into Flashinfer.
My pleasure. It's been a fascinating conversation.
It has. And to our listeners, thanks for tuning in.
Until next time, stay curious.